All right. Hello, good afternoon, GrrCON. So my name is Ian Odette. I am here to give a talk on a tool that I wrote called ProbeSpy, which essentially helps you to use potentially useful information that's divulged by unassociated wireless client devices to get bits and pieces of information that might be less than desirable to disclose. So, as it says here, I am an information security consultant for CDW. So what we're talking about wireless probe requests, what they are, when they're sent, what they can tell us, and how we can harness their power. So just to start, 802.11 probe request is essentially a packet sent by an unassociated wireless client device while it is attempting to associate with an access point, presumably one that it's associated with before. So a couple of bits of information that are included in this packet are the sending radio's address, the MAC address, the sending radio's capabilities, and optionally the SSID of the network that it's attempting to connect to. All right, so what can we determine from this? So the sending radio address, the initial spec was intended for this to be the burnt-in MAC address of the device that was sending the probe request. So theoretically, that would be a unique address that identifies that device as sending the probe request. However, recent advancements and the prevalence of this sort of information disclosure has made it so that a lot of device manufacturers will attempt to obfuscate this data. So they will either randomize every probe request, or the MAC address in every probe request they send, or they will randomize them on some regular basis, or randomize a segment of the MAC address as they're sending out probe requests, since you only actually need to include the burnt-in MAC address during like actual networking activities like association or actually interacting with the access point to send network traffic. So we can potentially determine the burnt-in MAC address of the device sending the probe request. Additionally, we can determine the sending radio's capabilities. This is stuff like the frequency that the radio will transmit and receive at, the modulation schemes that it supports, the encryption schemes that it supports, other features like Wi-Fi Direct and stuff like that. Now, there are a whole bunch of different features that are included in this area. So my initial hope when I was looking at this was to identify if there was a way that you could look at all of the specific features that were supported by a specific chipset and then maybe use that to identify, a given packet as being sent by a range of chips and thereby, potentially identify the manufacturer or make of the device. Now, unfortunately, there's a paper by the U.S. Naval Academy that goes into a whole bunch of wireless information disclosure techniques like this. And in their research, they found that these features tend to change like all the time when they're being sent out. So unfortunately, it's not very useful as a device fingerprinting method. And finally, we have the SSID. Now, the SSID is an optional field that's included in a probe request. A directed probe request indicates a specific SSID that the device is attempting to connect to. A broadcast probe request essentially leaves that field null and attempts to induce any access points around it to return a beacon packet saying, here's my SSID, here's all my junk, you can decide if you want to connect to me. So lots of devices, again, that are attempting to avoid this kind of information disclosure will only send broadcast probe requests, except in cases where the access points are hidden, because the Wi-Fi client device needs to actually, attempt to get the access point to, identify itself so that it can do the association process. So again, not all devices are going to be sending out directed probe requests for all the networks that they've connected to. In fact, most modern devices won't do it at all. Now, SSIDs aren't designed to be unique. They're mutable, they're changeable. I'm sure you've all pulled a router out of its box and it has, the same SSID as like every other model of that router. Or plenty of Starbucks use the exact same SSID. But with the amount of key space that we have there, it's definitely possible that any given SSID could be pretty unique, if not entirely unique in the entire world. There are 32, there's space in the spec for 32 printable ASCII characters, so that's a lot of potential entropy. All right, so what can we do with this information? We can identify the sending radio address potentially. We can identify the SSIDs of networks that the device is attempting to connect to through the SSIDs that it's sending in directed probe requests. And for devices that aren't trying to obfuscate their MAC addresses or do it in a slow way, we can create lists of networks that a given device is attempting to connect to again. So at this point, we're kind of on an island with the information that we have. We have a list of networks that a given device has attempted to connect to. So it would be useful if we could find a little bit more information about this. Now, if you look at the list here, this is just a sample from a collection that I've done over the past year or so. And you can identify a few networks here that seem to pretty obviously give away information about where this person might have been. There's an IHOP wireless, Kohl's, Kroger, McDonald's, National Coney Island, etc., that indicate the patronage of certain businesses. Additionally, I'm from the Metro Detroit area, so the second network there is I Love Bamboo, Madison Heights. I recognize that as being somewhere that's kind of near me. With some Google Foo, you might be able to determine a little bit more about that location, which would give you, a little bit more information about where the person has been. So that essentially brings us into what I call behavioral profiling by SSID, which is just another way of saying that I can see that someone went to a Taco Bell because their device is attempting to connect to Taco Bell's guest Wi-Fi SSID. This is basically just operating on the premise that guest Wi-Fi deployments are everywhere and lots of people use them when they visit those establishments. And that those access points are giving away relatively obvious information about wherever it is they are. So a couple of examples here. For businesses, Panera Bread uses the SSID Panera, Target uses Target Guest Wi-Fi, Hilton uses H Honors. And additionally, as I mentioned before, there might be some SSIDs that give away information about very specific locations instead of just general identifiers for businesses or other things. These are two examples of guest Wi-Fi deployments at airports. So, given all that, what can we do? We can determine some behavior of the persons. I say persons because it's plausible that more than one person might be using a specific device for some of the devices. So we can determine businesses visited or patronized. Sometimes you can determine ISPs, but that's kind of a fuzzy indicator just because lots of ISP Wi-Fi, guest Wi-Fi access points are available for free to everyone, at least for a limited period of time. And also you might be able to determine stuff like, cities that the person has been to, or airports or whatever else. But it would be nice if we had a better sense of validation about these networks actually being what they say they are. Because as we said before, SSIDs are entirely mutable. I could name an access point, whatever I wanted, and put it in my house, and just because I connected to it doesn't mean that I actually went to, Romania or Cleveland or wherever. It also doesn't mean that I'm an FBI surveillance fan or anything else. So it would be really cool if we had a way to determine to have a third party to validate where some of these networks might actually be in the world, and it would be even better for networks that don't really give any useful information about where they might be. There are plenty of others on this list back here. Linksys. 0183, whatever. Like, there are plenty of these that I have no idea where they are in the world. So, that brings us to geolocation by SSID. Now, there are a couple of different ways that we might be able to accomplish this. One would be war driving, setting up Kismet and a GPS device in your car and driving around hundreds of miles to try and locate yourself the locations of all the different networks around wherever it is that you think you might find the networks that the people that you have detected probe requests actually are located. That's a lot of work, that's a lot of time, that's a lot of money, and it's really hard when you're wearing a ski mask like that, so I don't really want to do that. It would be really cool if I could get somebody else's recordings of where all these devices were. And there are some services already that do stuff like this. Wi-Fi positioning systems are essentially assistive location services that use the presence of wireless networks in order to help people locate where their devices are in the world. So essentially, most of them work by passively collecting, like while location services are turned on your smartphone or using some kind of survey equipment, they will go around the world kind of doing the war driving for you or crowdsourcing the war driving through the use of other people's wireless or smartphones or whatever, and then they'll send up, all the digests they get of, all the networks that a given device saw at a given place, and they kind of aggregate them all together. So then when I'm here sitting in this conference room, or whatever it is you want to call this room, and I can't get, reception for GPS signaling that's coming down from satellites because we're indoors and stuff, my phone can basically say, I can see all of these networks around here, and send it up to this service, and that service says, well, I saw this network, within like 12 feet of this latitude and longitude, and do it again for network number 2, network number 3, et cetera, and then kind of evolve a Venn diagram of the places where it has the most confidence that I actually am in the world. Now, there are a handful of services that do this. Skyhook Wireless is one, Google runs one, Mozilla runs one. There are a whole bunch of different services that run this kind of thing. But the main problem for our purposes is that, one, they usually require that you submit the BSSID, that is the burnt-in MAC address of the access point, or not the burnt-in MAC address, but the MAC address of the access point, which we don't get from a probe request. We only get the SSID, the display name. And they usually require that you submit more than one BSSID at a time, because presumably they don't want people just cycling through BSSIDs and giving individual locations for all those different networks and, building their own service off of the hard work that they're doing, siphoning all these locations from everyone else. So, fortunately, we do have a service that's available to us called wiggle.net, which kind of sort of gives us a best of both worlds scenarios, but not quite exactly as good. Essentially, it's a community-driven war driving website. So you can download their app. They have an app for Android. It's not really a shameless plug. I don't have anything to do with them. I give them money to operate on their API. Or you can, set up your Kismet setup in your car and submit your captures that way. And anyways, they kind of like aggregate all those things, and they give you an interface through which you can attempt to search through all of the aggregated information that everyone has donated up to Wiggle. So it also does cell towers too, which is kind of neat, but not really useful for our stuff. And again, the most useful part of Wiggle for us is the fact that it's searchable by the parameters that we need to use in order to get any useful information out of this. That is primarily the SSID. Now, they do have a free option that you can kind of like, log in and, grab the cookie and, interface with their with their post service in order to get this same information out of the service. That is rate limited though, and depending on how many probe requests you're attempting to locate, that might force you to like wait multiple days. So they do have a commercial API that's in beta. It's pretty cheap. So that might be something that works for you if you're attempting to do this. That's what I'm doing anyways. All right. So as far as I'm concerned, when we're looking at locating SSIDs, because of my API usage and budget limitations, and because of the fact that I'm not really a very good programmer and I just kind of toss this all together in Bash, as far as I'm concerned, duplicates mean uncertainty. So if I query Wiggle and I get more than one response for an SSID, depending on whatever parameters I'm searching by, I basically say, I don't know where this thing is, so I'm just going to ignore it. But sometimes we get lucky. And sometimes you can get even more lucky, say for instance, if you were to collect a whole bunch of probe requests from around the Grand Rapids area, and then you were to bound your search to only search for SSIDs that were within like 60 miles or so of Grand Rapids, if you were confident that a lot of people that were sending the probe requests that you collected lived in that area, and probably get less duplicates than you were if you were searching the entire world. So, covering what we've gone so far. So, what can we do? We can determine information about some SSIDs with some confidence, that being, the location, through the latitude and longitude, the network encryption type, and the last time that the network was seen. There's just one little additional bit that I added onto this from the last time I gave this talk, which was essentially just grabbing a little bit of additional locational metadata about these addresses. Now, we do actually get the address in addition to the latitude and longitude from Wiggle itself. But I was most interested to know if there was a way for me to determine without, manually looking at Google Street View for every single address that I found that I had located, whether a given address might be commercial or residential, because as you'll see in a minute from the different potential uses that I've found for this, that seemed to be something that would be cool to do. So you can kind of sort of do this with Google's Places API. I think my difficulty with using this was mostly a function of the fact that Wiggle does not always give you a spot-on location for whatever network you're searching for. It's kind of a general area. So lots of times you'll get a response that essentially just says, yep, that's a street address. And I'm like, I know, Google, that's not very helpful. But sometimes we get other stuff that's pretty useful. All right, so again, summarize all the capabilities we have at this point. We're able to generate a list of devices and the SSIDs that they've connected to, or at least that they're attempting to connect to. We can use known SSIDs to determine some known behaviors about the users of the device. We can use wiggle.net to search for the locations of some SSIDs, and we can determine the locational metadata for those located networks. Now, I'm going to attempt to give a demo here. I hope it will work, although we will see if my network access allows us to. So I've actually been collecting probe requests from you guys while we've been doing this presentation. I'm just using AeroDump to dump all this stuff out. You could use plenty of other tools to do it, but that's what I happen to be using. We're just going to close that right quick. All right, so this is running the tool. It's essentially processing the PCAPs, searching for probe requests that were identified from all the different devices that it saw stuff coming from. It is attempting to do an SSID lookup for all of the new SSIDs that it's found through Wiggle, but LTE in this room is probably not great, so that might not work. So I'm going to leave that for a minute, and maybe we can look at this and at least see some of them. That's pretty small. There it goes. And it's going to take a while. And I'm 16 minutes in, so I'm just going to... All right, so just operating off of this little bit that we have here, we do actually have another example that we can give. Anyways, for this device, so we can see the MAC address that it identified for this profile. We don't have a known manufacturer because the OUI prefix wasn't identifiable. Excuse me. We have 3 of the 4 networks that it was searching for that it wasn't able to find any information about. One of them it was able to. It looks like it's 2-48. It's kind of a weird address, and this is what we're getting from Google in Middleton, Ohio. And again, it says that it is a street address. Hoping this is just going slow. So I am going to just bring up one of my other... All right. All right. Loading up all the stuff, giving people seizures. That's cool. All right. So let's see if we can find one here that is a little bit more impressive. Maybe gives a little bit more information. All right. So for this one, again, device ID, or the manufacturer of the device wasn't identifiable because we don't know the OUI prefix for the MAC address. So for the networks that we weren't able to locate here, we do have 2 here that are, I don't know how well you can see that. It's kind of, anyways, you can see that 2 of them are bolded. The 2 that are bolded indicate that we have some behavioral profile information based on the SSID that's there. One of them indicating that the person has visited the Toronto-Peterson airport. Another one indicating that they visited the MGM resorts. And then a network that was located apparently in Spain. So that's kind of neat. It might give us some useful information if we were attempting to find more information about this person. Here's another one. An Apple device that was attempting to locate 16 different networks. We found 2 of them. From the behavioral profile information, we do have Fly COS, which indicated that they visited Colorado Springs, H Honors indicating that they're a Hilton customer, Sheraton as well, United indicating that they're a United customer potentially, and McCarran Wi-Fi. Can you guess that I collected this from DEF CON? Because I did. Anyways, so this is just kind of another demonstration. Oh, hey, that's the same one that I just used right here. That's cool. So you can kind of see some of the information that we can determine about people just based on the probe requests that we have here and the information that we're attempting to look up about them. We can't be 100% sure about the veracity of all of this data, but some of it might be accurate, and depending on our purposes, some might be enough. So limitations. So right now, we can provide locations, but we can't really provide any kind of a timeline for when anyone happens to visit any of these networks or attach to any of these networks. That's just a limitation in the amount of information that's being disclosed by the device. Pretty much the closest we can get is if we get a hit on Wiggle and we only have one response, then we can use the first seen, last seen date in order to establish some kind of a timeline for when they might have possibly been attached to it, but it's really a pretty broad guessing game there. Additionally, this is purely using, it's a purely passive tool. It's just listening for packets and then attempting to determine information from those packets. So for a lot of modern devices, again, they will either, only send out broadcast probe requests. They'll attempt to obfuscate their MAC address. They'll do, things that prevent us from getting any kind of useful information in this way. I was attempting to get one of the techniques that I've heard about that allows for this kind of disclosure, at least to a certain degree for more modern devices. It's called beacon honeypotting, where essentially you can present a beacon for a network that you think that a given device has connected to in the past, and that will initiate an association request, which will not only reveal the fact that the device, is now attempting to connect to the network, and presumably might have connected to it in the past, but also reveals the burnt-in MAC address of the device, allowing you, if you had multiple, allowing you, if you were able to find, multiple different networks that the device responded to, kind of, continuing to create that profile and identify it as coming from a specific device. And finally, Wiggle's database is great, but it has a lot of gaps. It's a community-run service. It's essentially all volunteers in that, people are volunteering their war driving stuff up to them. So there are a lot of gaps. There are a lot of places that haven't been covered in years. There are a lot of places that haven't been covered at all. It's the best that I am aware of for this kind of stuff, just again based on the parameters that I'm attempting to search for. But it would be nice if there was another source that had a little bit more coverage, a little bit more reliability. All right, so as far as practical applications go, I do penetration testing. This is more of like a surveillance-focused tool. I just kind of built it as a proof of concept. So I had a little bit of trouble kind of wrapping my head around the best potential applications for our purposes, but we're able to determine at least a few with the help of my colleagues. So one would be to build a phishing pretext. If we're able to collect packets and be reasonably sure that we weren't being contaminated by people who worked in another building or something, maybe we could look at the directed probe requests, attempt to locate an SSID that belonged to a local business, and if there was one local business like a diner or whatever that showed up in a whole bunch of people's phones or laptops or whatever, we could reasonably be sure that a bunch of people went to that establishment, and maybe use that as use that as some kind of bait to attempt them to get them to interact with whatever malicious whatever we were attempting to get them to interact with. The next one, which is where the distinguishing commercial from residential addresses comes in, would be to be a totally creepy stalker, attempt to identify addresses that that looked like they were residences from a given person's profile, and then get in a nondescript white van, travel to their house, attempt to locate attempt to determine that the device was actually in the house, and then use your directed antenna to attempt to disassociate them from their home network, associate them to your network, and then do whatever mean evil things that you might do if you were a bad person. Does anyone have any questions? All right. I'm gonna see if this is finished, because I still have a minute. It's still going. But it's close to the end. So.
Where are you going from here? What
I mean, the directed attacks, attempting to convince devices that are otherwise well protected from this kind of disclosure to disclose information about themselves would, make this a little bit more relevant, at least, since a lot of, modern operating systems, iOS, newest OS 10, I think newest Windows 2, like basically newest of everything except, a handful of Android manufacturers that apparently don't really care about changing this kind of stuff, or making it so their Wi-Fi stacks treat this properly and, obfuscate this kind of information. But even they still might be vulnerable to certain type of, directed disclosure inducement attacks. So that would probably be where I would focus my efforts on next if I were to continue to work on it. All right. Thanks for coming, everybody.